Welcome back to AP Calc 4.2, Part 6, so motion affected by gravity. All right, so although this concept is not tested on the AP Calculus exam, it provides a great environment in which we can understand particle motion. When an object is subjected to gravity, we can determine its position, velocity, and acceleration based on the formulas to the right. So note that V of 0, or B sub 0, is the initial velocity, and that a sub 0 is the initial acceleration. So if you guys see a little 0 right below, that means pretty much those two things. So example 7, a rock thrown vertically upward from the surface of the moon at velocity of 24 meters per second reaches a height of s of t equals negative 0.8 t squared plus 24 t's in meters t seconds. All right. So again, that's what we're looking at. Okay, and then it says, so thrown upward at a velocity of 24 meters per second, and then it reaches that height. So find the rock's velocity and acceleration as a function of time. So pretty much in order for us to do this, so if you guys notice here, the initial position, if it's upward from the surface of the moon, so we can say that from the surface of the moon, it's at 0, and then it's going to take off at 24 meters per second, right? So the velocity function, in this case, we would see it at the derivative of this, right? So V of t is equal to negative 1.6 t plus 24. And if you guys notice, it gives us the initial velocity is 24 meters per second. So now we want to find the prime. So V prime at t is equal to a of t, which would be just negative 1.6. All right. So those are two things we're asked for. Find the rock's velocity and acceleration as a function of time. So this is the first one. This is our first function, and this is our second function, which is just a constant function. All right. So part B, how long will it take the rock to reach its highest points? So when the rock is reaching its highest point, right, so it travels like in a parabolic shape like this. So the speed, right, is positive, and then it changes sign to negative because it's going down. So therefore, this is a point right here where the velocity has to be equal to 0. So we're looking to see where does phi of t equals 0. And in order for us to find that, we just pretty much set the other equation equal to 0. So we're going to say negative 1.6 t plus 24 equals 0. Subtract 24 from both sides. And you get negative 1.6 t equals negative 24. Divide both sides by negative 1.6, and you get t equals 15 seconds. So it takes 15 seconds for it to reach its highest point and then start dropping back down. All right. And then let's see how high did the rock go. So we know it took 15 seconds to reach its highest point. So we're going to go back to the position function, s of t, which is, again, negative 0.8 t squared plus 24t. We substitute the number we found here. So that's going to be s of 15 equals negative 0.8 t. I'm sorry, 15 squared times 15 squared plus 24 times 15. All right, so again, use a calculator. Make sure you guys are doing that. In this case, you're going to get 180 meters. And that would be how high it got before it started to drop back down. Okay, and then for the next one, we have how long did it take the rock to reach half its maximum height? So in this case, half its maximum height would be 90 meters, right? So if you guys can visualize this, so you're looking to see if this was at 180, now we're looking to see where did it hit 90 meters, which was halfway there. And if you guys notice, it's going to be at two different instances, right? Okay, so here you guys would use pretty much, you would just set it equal to 90, right? So you want to say negative 1.8 t, right? How long did it take for the rock to reach maximum height? Actually, we're setting it equal to the position function, my bad. So that would be negative 0.8 t squared plus 24t equals 90. And then from there, you just like subtract, set it equal to 0. So negative 0.8t squared plus 24t plus minus 90, minus 90 is equal to 0. And then here, use your calculator, right? Quadratic formula. However you guys want to reach your conclusion, you're going to find out that t is approximately equal to the first instance it reaches 90 meters is when it hits 4.43433 seconds. And the second instance, right? So it'll be the second instance is when it hits 25.567. All right. So here, well, there's two times again. It says we will assume that the problem is more concerned with the first time since it's 4.433. Okay, so but it does hit it twice. So that's one of the things you guys want to be careful about. Okay. And then let's look at this. So how long was a rock aloft? How long did it take for it to take off from the floor and then land back to the floor, right? So you're looking for these two instances. So that's pretty much when S of t is equal to 0 when it hits the floor. So here we're going to see again negative 0.8t squared plus 24t equals 0. And then subtract 24t from both sides. You're going to end up with negative 0.8t squared equals negative 24t. You can divide both sides by negative 0.8t. All right, and that gives us t equals a total of 30 seconds. And then the last part of the question, it says, find the rock speed when hitting the surface of the moon. So how fast was it going when it hit the floor? So remember, here the keyword is speed, which is the absolute value of the velocity at that moment. Okay, so we're looking at the absolute value of 30. So here, let's look at that. Let's plug it into our velocity equation. So the absolute value of negative 1.8 times 30 plus 24. And that's going to give us a total of, negative 1.8, negative 1.6. No, 1.6, right? Yes, negative 1.6, my bad. Okay. And then from there, we can come to the conclusion that this is going to be equal to 24 meters per second. So that's how fast it was going when it hit the floor.